we have worked with like terms before when we worked together with the algebra group. What were like terms? Who remembers what like terms were? Yeah. Yeah, they were terms that were very much alike in the fact that they carried the same variable with them, and that enabled us to do what with them? If they were like terms, what did we do with them a lot of the times? Very good. We either added them or we subtracted them. We cannot add or subtract terms that are not like. Okay? So what they're going to do is kind of run us through. And algebra, if you've got a minute to kind of take a peek too, this is going to be right up pretty similar to the same kind of stuff that you were doing as well. So you see problems like this. So then not only are we going to evaluate the like terms, but we're also going to solve for the equation. So I have a 3x and a 2x. Can I add those together? Are they like? Together they will give me 5x equals 25. From here, we are going to do what to both sides? Alex. Divide by 5. X will equal 5. Plug it in. What's 3 times 5? 15. What's 2 times 5? 15 plus 10 is 25. So it works. And so not only are we going to be solving with the like terms, we're also going to be then solving the equation. Now, they'll get a little bit tricky, but not necessarily tricky in the fact that it's impossible to do. Tricky more so in the fact that they're going to try to throw you off a little. A 3n minus 40 plus 2n is going to equal 15. Now, when we look closer, what we want to do is try to simplify the like terms as much as possible to try to clean things up. I have a 3n. What kind of a 3n is that? Positive, because it does not have a negative in front or a subtraction sign in front of it. Combined with another positive 2n should give me, we're adding them. Let's bring down that negative 40, and it equals 15. So it's very similar then to the same kind of work that algebra was doing today. More like a multi-step problem. Opposite subtracting 40. 5n equals 55. Divide both sides by 5. N equals 11. Plug it in. What's 3 times 11? 33. 22. 33 minus 40, negative 7. Negative 7 plus 22, 15. It works. Bless you. Bless you. Give it a shot. 4x, negative 1x. How many x, Alex? 4 minus 1? 3x, right? Okay. And then negative 9. Add 9 to both sides. Divide both by 3. X equals 10. Plug it in. 4 times 10, 40, minus 9, minus 10 is equal to 21. 40 minus 9 is 31. 31 minus 10, 21. What property is going to be used here? Very good, Sophia. Distributed property. So let's use it. 2 times S. It's an S, not a 5. 2 times S. 2S. Positive 2 times a negative 1. Negative 2. 2 times 1, 2. Right? Equals 6. Now we're set. Now we're ready to go. Opposite of subtracting 2. 2S equals 8. Yes, sir? Because I'm multiplying this positive 2, and I'm multiplying it to the negative 1. Yeah, if it's in front, we'll call it negative. That's just the way it is. I have to accommodate it that way. Divide both by 2. S equals positive 4. Check it. 3 to 4. 4 minus 1 is what? On the inside of the parentheses? 3. 2 times 3? 6. Give it a shot. Here we go. Here we go. Distributed property. 8 times x, 8x. Yes? 8 times what is that? Is a negative equals 16. Okay, hold on. Opposite then of subtracting 8, add 8, 8x equals, divide both by 8, and x equals 3. Plug it in. 3 minus 1 is 2. 8 times 2. Three times x, 3x. 3 times 1. Subtract 3. Divide both by 3. Plug it in. 1 plus 1 is 2. 3 times 2, 6. You're on tape, you know. So can I do anything with this 5 right now? Or can I just leave it? Let's just leave it for now. Well, you could, but let's just leave it for now, and then let's deal with the elephant in the room, this distributed property, okay? Positive 2 times a positive x. Positive 2 times a negative 2 equals 19. Is there anything else on this side that I can clean up? Alex? I have a 5 and a negative 4. Well, 5 minus 4, 1. So 2x, it's a positive 1, equals 19. What? Subtract 1. Divide by 2. X equals. Did I say it was right? What did you have? 7? Okay. Okay. That's fine. Sure. So you went in pieces. Yeah. So he got rid of the positive 5 by subtracting the 5, and he got rid of the negative 4 by adding 4. He just did them separately. He didn't combine them together to get positive 1 on this side. He did them separately. That's okay. It's the same thing. Caleb. Yeah, crystal clear. They can pinpoint who's talking, how much they're talking. Anytime we have problems like this, you can kind of go at them, as long as your strategy is correct, you can go at them a number of different ways. My advice to you would be worry about that first, okay? So let's carry this 2y down. It's a negative 3 times a positive y, which is a negative 3y. The negative 3 times the positive 4. Negative times positive. Negative 12. So now here is what we have. Now it's our job to try to clean things up. A positive 2y minus 3. 2 minus 3. Negative 1y minus 12. Here's my 13. Opposite of subtracting 12, add 12. Add 12 to 13. Now, I can't have a negative y. I can't have a negative 1y, because that y is being multiplied by the negative 1. Opposite, divided by negative 1. Negative divided by negative gives me a positive y. Positive divided by negative 1 is a negative 25. Okay. It's a tough one. It's a tough one. Let's do this. Let's do one more. We got time for one more. And then we'll revisit this and we'll finish this off tomorrow. How's that? There we go. So 3 times 7, 3 times a negative 2 equals 9. I need to get rid of this positive 21 by doing what? So this is just a regular 9. So 9, whoops, got a little ahead of myself. 9 minus 21, negative 12. So a negative 6y, a negative 12. Divide both by negative 6. about the 6? You could. As long as you add 6y. But you can't add it to 9 because it's not like terms. All right, redo. Yeah, yeah.